Hello students, welcome to another session of this differentiability, and in this session we will be doing some important problems on second order derivatives, and I promise you in the final exam you will get 5 marks surely. So let's begin. We will be doing some 10 examples almost, so without wasting much time. So write down, and if you feel my speed is little bit high, then you can keep your video at 0.75 speed. Okay, so in the playback you can go and set your speed. So let's begin. So here is the first example. So they are all asked you to prove once very first simple example. If y equals to a into sin x plus b into cos x, then prove that d square y by dx square plus y equals to 0. Okay, so you are given y is equal to a sin x plus b cos x. Okay, so differentiate with respect to x. So dy by dx equals to a as it is. A is a constant and derivative of sine is cos x plus, okay, b as it is, and derivative of cos x is minus sin x. So I can write this as minus and sin x to save one step. Derivative of cos is minus sin x, so I can write minus out here. Okay, now we are concerned with second derivative. Okay, ಇಲ್ಲಿ ಏನು ಹೇಳಿದ್ದಾರೆ, ಸೆಕೆಂಡ್ ಡೆರಿವೇಟಿವ್ ಪ್ಲಸ್ y equal to 0 ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಒನ್ಸ್ ಅಗೇನ್, redifferentiate this. It's a simple example. Differentiate with respect to x again. So derivative of second derivative of this, that is rederivative of this is d square y by dx square. Here a into derivative of cos is minus sin, so I write minus here, and sin x minus b into derivative of sin x is cos x. Now you are asked to prove that d square y by dx square plus y is equal to 0. So I can write in this fashion. If I take minus common, see here what you will get, a sin x plus b cos x, and what it is, this is your original given function. You are given y, this is your y. Okay, because from given this is nothing but y, so I have replaced. Very simple. So bring y this side So d square y by dx square plus y equals to 0. So very easy you can crack such examples. Okay, so go on writing. Just listening or watching doesn't help you. So similar one example. Right. If y equals to 5 cos x minus 3 sin x, okay, you're asked to prove the same thing. Prove that d square y by dx square plus y equals to 0. Same way you have to do. Pause the video, you can try, you will get, I'm sure. So y is equal to 5 cos x minus 3 sin x. Okay, so this is your given. You may call it as 1. As usual, differentiate with respect to x. So dy by dx is equals to 5 into derivative of cos is minus, so I can write minus in the beginning, minus 3 into derivative of sin x is cos x. Okay. Redifferentiate it. Differentiate with respect to x. So derivative of dy by dx is, we can write d square y by dx square minus 5 as it is. Derivative of sine is cos x minus 3 into derivative of cos is minus sine, and this minus becomes, it is plus. So I can write it as plus sin x. Okay. Now take minus common from this. So if you take minus common, this becomes minus 3 sin x. Y minus is taken because we have to express in terms of y. So this turns into your y. If you compare this with your y given, so this is your y. From 1 you can check. Your y is 5 cos x minus 3 sin x. So ಇವಾಗ ಅದನ್ನ ಈ ಕಡೆ ತಗೊಳ್ಳಿ. Okay, bring this side. So d square y by dx square plus y equals to 0 as earlier. Okay. Now see here one more very important as per my knowledge. It was asked many times. If y is equals to three cos log x plus 4 sin log x, 4 sin of log x, instead of 3 4 you may get a b also constant. Prove that x square y2, sorry, through that x square plus 1, sorry, through that I was right, x square y2 plus xy1 plus y equals to 0. Okay, so important one, right. So right, given as y is equal to 3 cos log x plus 4 sin log x. Okay, so here y1 means first derivative, y2 means second derivative. Okay, so if you are given this form, then you can write its derivative in this form also. So differentiate with respect to x. Okay, so derivative of y, I write y1. Either you can write dy by dx. ಇಲ್ಲಿ ಯಾವ ತರ ಕೊಟ್ಟಿರ್ತಾರೆ ಆ ತರ ಬರೀರಿ. 3 into, carefully, it's a composite function. Cos is a function of log x. So the derivative of cos is minus sine. So minus sine of log x into derivative of log x is 1 by x. Similarly, 4 into derivative of sine is cos of log x, and inside we have log x, so derivative of log x is 1 by x. Okay, so ಈ ತರ ಏನಾದರೂ ಡಿನಾಮಿನೇಟರ್ ಬಂದ್ರೆ ಅದನ್ನ ರೈಟ್ ಗೆ ತಗೊಳ್ಳಿ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಇನ್ನೊಂದು ಸ್ಟೆಪ್ ಬರೀತೀನಿ ಫಾರ್ ಯುವರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. minus 3 sin log x plus 4 cos log x whole divided by x is common denominator here, and we have x here, so I can write x out here. Okay, now you can transfer x this side, because here we want expression in this kind. So cross multiply, bring this x this side, adenagate, you'll get xy1 equals to minus 3 sin log x plus 4 cos log x. Okay, now you can differentiate with respect to x. Okay, now look, in the left hand side we have the product of x and y1. Okay, so product rule you need to apply. Product rule haki, first function derivative of y1. Okay, derivative of y1 we write it as y2 plus y1 as it is, and derivative of x is 1. Either you can write or don't write. Derivative of x is 1. On the other side, as earlier, in baritira, you write minus 3 as it is. Derivative of sine is cos of log x. Puna derivative of log x 1 by x. Okay. Similarly out here, 4 derivative of cos is minus sine, so I can write minus here. Derivative of cos is minus sine, so I can write minus here. minus 4 sine of log x into derivative of log x is 1 by x. Okay. Now see here, we have x common in the denominator and minus in the numerator. So I can write in this form, minus outside 3 cos of log x plus 4 sine of log x, because minus is taken outside, so it becomes plus, divided by x. And this side it is xy2, y1 into 1 is y1. This is xy2 plus y1 minus, okay, this is your original given function, so I can write it as y, okay, because from given this is your y. Now you can cross multiply, bring x this side, so one can write directly x into x square, okay. So but those who can't understand, for them I am writing this minus y as it is. So x into x square, y2, x into y, y1, xy1, and minus y this side, so it becomes plus y equals to 0. How easily you can crack this example, and concentrate especially on this. Okay. So instead of these 3 and 4, they make you a and b. Okay, you'll get the same result. If you, this is a and this is b, you'll get same result. So better, if you want, you can try that. Let's have one more example. These are all from the textbook, from the exercise 5.7. Write this. If y equals to, again this is also important one, tan inverse x, was asked many times, tan inverse x whole square, then prove that x square plus 1 whole square y2 plus 2x into x square plus 1 y1 equals to 2. Okay, so again, one of the important problem, I said definitely will be going to get one question for 5 marks from this part. Okay, so given y is equal to tan inverse of x whole square. Okay, this is your given. Differentiate with respect to x. Okay, so here in terms of y1 and y2, so better you write derivative of y is y1, I write. Now see here, in the last class also I gave you this, note down this, d by dx of f of x power n is n into f of x power n minus 1 into derivative of this inside function, that is f dash x. This rule you have to remember whenever you find powers. Okay, so according to that, it becomes 2 into tan inverse of x, 2 minus 1 is 1, into d by dx. F dash means derivative of this tan inverse into d by dx of tan inverse x. Okay, so 2 tan inverse x into derivative of tan inverse x, 1 by 1 plus x square. Okay, now you can bring this 1 plus x square this side. So this is 1 plus x square into y1 equals to tan inverse x. Okay, now you can differentiate with respect to x again, because we are interested in a relation consisting of y1 and y2. So you have got one relation with y1, so y2 barbekadre you need to differentiate once again. Now you have to apply product rule. So 1 plus x square into derivative of y1 is y2 plus y1 into derivative of 1 plus x square. Derivative of 1 is 0 and x square derivative is 2x. One can write directly 2x. This side 2 into derivative of tan inverse x is 1 by 1 plus x square as earlier. So you can write 2 by 1 plus x square or 2 into 1 by 1 plus x square. Okay, so one more step. So you can write 1 plus x square or x square plus 1 y2. So 2x into y1 is 2x y1, which is equals to 2 by 1 plus x square. Okay, now cross multiply. Bring this 1 plus x square this side. So 1 plus x square into 1 plus x square, you will get 1 plus x square whole square. Okay, similarly into y2, this into this, 2x into 1 plus x square y1 equals to, you remain with 2. I suppose you understood. Okay, you brought this 1 plus x square this side. So 1 plus x square into 1 plus x square is 1 plus x square whole square. Next this into this, 2x into 1 plus x square y1 as it is equal to 2. So please redo it for better understanding. Let's have one more example. If y is equal to sine inverse x, then prove that 1 minus x square into d square y by dx square minus x dy by dx equals to 0. Okay, you may be asked in terms of y2 also. 1 minus x square y2 minus xy1 equal to 0. You can be asked in this form also. Prove that 1 minus x square y2 minus xy1 equals to 0. Okay. As usual, very simple. Given y is equal to sine inverse x. Differentiate with respect to x. So dy by dx is equal to derivative of sine inverse is 1 by under root 1 minus x square. Okay. Now there are two techniques. One is, if you get a term like in the square root, you square and differentiate. Otherwise, cross multiply and apply the product rule. Okay. So I prefer by squaring. Okay. So if I take this as a y1 or squaring on both sides, whenever you get a square root term, better is square it. Okay. So what will you get? Dy by dx whole square equals to, if you square root get cancels, 1 minus x square. Okay. Now you can differentiate or cross multiply and differentiate. Both options are there. Okay. So you can bring this side 1 minus x square dy by dx whole square equals to 1, or I can write for better understanding to avoid confusion, dy by dx means y1 whole square equals to 1. Okay. Now you can differentiate. Differentiate with respect to x. So 1 minus x square, first term as it is, product rule you need to apply. I will write in detail. D by dx of second term, that is y1 square, plus y1 square, this second term as it is, d by dx of 1 minus x square. Okay, suppose you follow. So derivative of right hand side is 0 because it's 1 constant. Now 1 minus x square, here you need to take care of this. Please note down this. Please note down this. D by dx of y1 square, like how derivative of x square is 2x, derivative of y1 square is 2y1, and you need to differentiate this base function, that is derivative of y1. So d by dx of y1, and that gives you y2. Okay, so remember this, derivative of y1 square is 2y1 y2. Okay, so please remember. So I write directly, derivative of y1 square is 2y1 into derivative of y1 is y2, plus here y1 square as it is, and derivative of this, derivative of 1 is 0, derivative of minus x square is minus 2x. The rate of x square is 2x. So you can write minus 2x equals to 0. Now see here what is common. Otherwise I'll write one more extra step. 1 minus x square 2y1 y2 minus 2x y1 square equals to 0. Okay. So look here, what is common here? We have 2 common and y1 is also common. Okay, so if I take 2 and y1 common, always whenever you square and differentiate, 2y1 is to be common. So you left with 1 minus x square y2 minus x remains and 1 y1 remains equals to 0. So divide by 2 y1. So what you left with? You left with 1 minus x square y2 minus x y1 equal to 0. If we divide by 2y1, 2y1 cancel this side. 0 by 2y1 is 0. So this is your required result, or you can keep it in this fashion. 1 minus x square y2 means d square y by dx square minus x into y1 means dy by dx. Okay. I hope little bit lengthy, but can be done if you practice 2-3 times. Okay, so let's have similar example. You take it as a homework. If y is equal to cos inverse x, prove that same result, 1 minus x square y2 minus x y1 equal to 0. Okay. So you may ask in this fashion also. For textbook you are asked in this fashion. If y is equal to cos inverse x, okay, you are asked in this fashion. If y is equal to cos inverse x, then express y, sorry, d square y by dx square. We are asked to express d square y by dx square in terms of y alone. Okay, so I'll just show you. First you need to prove this. From given y you have to prove this. Okay, so after proving this, you have to write this as 1 minus x square y2 as x y1, and we are asked to express second derivative in terms of y. So I can write bring this 1 minus x square this side. Now you need to convert x terms in terms of y. Okay, so look here, x by 1 minus x square as it is, and y1 means derivative of your y. What is derivative of your y? Derivative of cos inverse. y1 means, okay, So your y is cos inverse x. So its derivative is minus 1 by under root 1 minus x square. So I can write this y1 as minus 1 by under root 1 minus x square. Further, but x is what? Look at this. Y is cos inverse x, so x is cos y. So x can be written as cos y. Looking at this. Okay, one can skip this if they are not understanding. Now you can substitute in terms of y. So this is cos y by 1 minus cos square y into minus of 1 by under root 1 minus cos square y. So replacing x in terms of y. Very simple now. This is cos y. 1 minus cos square means sin square y. This minus I can keep out here. 1 divided by root of 1 minus cos square, that is root of sin square y so you can write minus cos y by sin square y into this becomes sin, so you can write directly sin cube y. Or further if you want, cos y by sin y one term into 1 by sin square. Here only you can write, no problem. Cos by sin into 1 sin square remains. This is minus part y into cos x square y. So this is your second derivative. So in this way you can prove if it is asked, but I don't suppose it will be asked because there are some other standard examples are there. Okay. So let's have few interesting one. Right. If y is equal to 3 e power 2x plus 2 into e power 3x, show that d square y by dx square minus 5 dy by dx plus 6y equals to 0. Okay, so write the given. Y is 3 e power 2x plus 2 e power 3x. So differentiate it. Okay, so differentiate with respect to x. So 3 into, remember, derivative of e power 2x. Derivative of e power is e power, but what in the power? 2x. So derivative of 2x is 2. Composite rule you have to use. Similarly, 2 into e power 3x, e power 3x derivative is e power 3x, and 3x derivative is 3. So what will get? 3 into 2 6 e power 2x. 3 into 2 is 6 e power 3x. This is your dy by dx. Okay, so redifferentiate it. Differentiate with respect to x again. Okay. So what is the derivative of dy by dx? It is d square y by dx square equals to 6 into e power 2x. Derivative is e power 2x, and one more 2 comes here. Derivative of 2x is 2. Similarly out here, 6 into e power 3x, and derivative of 3x is 3. So 6 2s are 12 e power 2x plus 6 3s are 18 e power 3x. So ಇಲ್ಲಿ ಏನಾದರೂ ಕಾಮನ್ ತಕೊಂಡು ನೋಡಬೇಕು whether it turns into y. Okay, so by taking common it doesn't turns into y. So I can go for the required result. We are supposed to show that d square y by dx square minus 5 dy by dx plus 6y equal to 0. Okay, so consider LHS. Now consider whatever you are asked to prove. You consider LHS. D square y by dx square minus 5 dy by dx plus 6y. Okay, you need to show that it is 0, so don't write 0. So substitute the values and show it 0. Okay, so what is the value of d square y by dx square? That is here. 12 e power 2x plus 18 e power 3x. Next, minus 5 as it is. And what is the derivative of dy by dx? That is the derivative of first derivative, that is dy by dx. dy by dx is here 6 e power 2x plus 6 e power 3x. So this you have to substitute. So dy by dx is 6 e power 2x plus 6 e power 3x. And what is y given? Okay, so it is plus this 6 as it is, and what is y is? Y is 3 e power 2x plus 2 e power 3x. This is your given. Okay, so we have substituted the value of d square y by dx square, dy by dx and y. Simplify ಮಾಡಿ 12 e power 2x, 18 e power 3x minus 5 3s are, that's 5 6 are 30 e power 2x plus into minus minus 30 e power 3x plus 6 3s are 18 e power 2x plus 12 e power 3x. Okay, now calculate or collect the terms with e power 2x. If you collect the terms with e power 2x, one can do directly. So better 12 minus 30 and plus 18. Next, collect the terms with e power 3x. So write the coefficients. 18 minus 30 here and plus 12 here. Clearly look at this. e power 2x into, it becomes 0 because 12 plus 18 is 30, 30 minus 30 is 0. So e power 3x into, same thing happens here, 0. So total you will get 0. So this is your required result. You are asked to show that this sum is 0, so it is 0. Okay. So let's have one more example. This is from miscellaneous exercise. Y is equal to, if y is equal to e power a cos inverse x, then prove that one minus x square into y2 minus xy1 equals to a square y. Okay. So y is equal to e power a cos inverse x. Even if it is sin inverse x, you will get the same result. So differentiate with respect to x. So derivative of y is y1 equals to e power derivative is e power. So as it is, I can write e power a cos inverse x into d by dx of whatever the function on the power of e. Okay. So it is derivative of a cos inverse x. Composite rule you have to use. Whenever it is possible to write in terms of y, you can write. So e power a cos inverse is your y. Okay, so I can write this as a y. E power a cos inverse is y into a into derivative of cos inverse is minus 1 divided by root 1 minus x square. Remember this, a constant, derivative of cos inverse is this. So I told you in the beginning, that's in the previous example, whenever you get a square root term, square it. Squaring on both sides. So what will you get? y1 square is equals to, here a square, y square, and square of minus 1 is positive, so I don't write, divided by 1 minus x square. Okay. Now you can transfer this side. One minus x square into y1 square equals to a squared y squared. Now you can differentiate with respect to x. Okay, carefully. 1 minus x square into, I told you in the last example, what is the derivative of y1 square? It is 2y1 y2. Just go back and watch it again. So derivative of y1 square, 2y1, and y1 is, derivative of y1 is y2. Plus y1 square into, derivative of this is minus 2x. Derivative 1 is 0, it's minus 2x. Equals to, on the other side, no need to apply product rule, a square is constant. And Now it is interesting, what is the derivative of y square? Derivative of y square is 2y, further derivative of y is y1. So just see here, note down this, d by dx of y square is like how I explained earlier, fx power n. So y square derivative is 2y, further derivative of y you have to write into d by, that is dy by dx. So dy by dx is your y1. So remember that derivative of y square is 2y y1 and derivative of y1 square is 2y1 y2. Okay. Now see here, I told you whenever you differentiate, square and differentiate, there will 2y1 will be common. So divide by 2y1. Okay, look at, here is 2y1, 2y1 and 2y1. So divide by 2y1. So what will get? 1 minus x square, 2 cancels, y1 cancels, y2 remains, minus, okay, 1 cancel, y1 cancels and 2 cancels, so 1 y1 remains and x y1. Okay, so x remains and 1 y1 remains. On the other side, 2 cancels, y1 cancels, so you're left with a square 1. So this is your given result. So if you want, you can try by taking e power a sine inverse x. Everything will be same, only here is plus, you will get derivative of sine inverse is 1 by root 1 minus x square, and everything will be same, just copy. Okay. So one more last one of this session. Okay, this is from your solved example. If y is equal to a e power mx plus b e power nx, show that d square y by dx square minus m plus n into dy by dx plus mn y is equal to 0. Okay. So write one such example I have done by taking specific constants here. In the same way, you have to perform this. Y is equal to e power mx b into e power nx differentiate with respect to x dy by dx is a e power mx derivative is e power mx and 1 m extra comes, so I can write here to avoid steps, e power mx derivative is m e power mx. Okay, actually what happens, derivative of e power mx is e power mx and derivative of mx is m, so better you can write in the beginning. Similarly, b into derivative of e power nx is n e power nx. Note on this, d by dx of e power ax can directly written as a e power ax. Okay, so better you note. Differentiate it again. D square y by dx square is a into m into So one more m e power mx comes. So I can write directly m square e power mx. Similarly, b into n e power nx. So n into n square e power nx will come. Okay. Now just write the LHS and show it is 0. Okay. So consider LHS. Whatever I asked to show, consider LHS. It is d square y by dx square minus m plus n into dy by dx plus mn into y. Okay, you are asked to show this is 0, so just substitute. So what is the value of this? It is am square e power mx plus bn square e power nx minus m plus n into what is dy by dx. The value of dy by dx is am e power mx bn e power nx plus mn into what is y. Y is a e power mx b e power nx. Okay, just slow down the video and just go back and or think of and then write. After that, just simplify. A m square e power mx b n square e power nx. Okay, now m into this. Outside minus is there, so every term is going to turn into minus. M into this, so that is a m square e power mx. Next m into this minus b mn. Look at this, m into this b mn e power nx. Next n into this minus a mn e power mx minus plus into minus minus n into this b n square e power nx plus this into this a mn e power mx plus mn into b mn e power nx. Okay, so there are 4 positive terms, 4 negative terms, and then think of cancellation. Okay, so this cancels with this b n square e power nx minus b e power n this. Similarly, this and this cancels, this and this cancels, so you will get 0. So this is all about the second order derivatives, and important one. I assure you, you will get definitely 5 marks from this. So you need to work once or twice, so definitely you will get 5 marks. Okay, so we will meet. This is all about differentiation. So if possible, I will solve problems from miscellaneous exercise. So till then, you practice this. Okay, we'll meet in the next session.